يعطيكم العافية. أتوقع يمكن العدد صار يمكن كافي، يمكن في عندنا حوالي 32 مشارك. يعني احنا بدنا نحاول نحكي بالعربي لأنه معظم المشاركين طبعا نحكي عربي. يمكن في عندنا بعض الزملاء نحكي جزء إنه أجانب، فممكن السلايدات تكون باللغة الإنجليزية، بس إنه يعني حتى تكون الفائدة أكثر بتكون إيش عندنا باللغة العربية. نرحب فيكم جميعا. يعني اسمحوا لي، أنا اسمي الدكتور أحمد السلايمة، مدير مشروع السيارات الكهربائية والهجينة، أو إنشاء برنامج دبلوم مهني في الجامعات الأردنية. في عندنا 8 جامعات أردنية مشاركة في هذا المشروع. احنا سعداء نكون في هاي الورشة الأولى، في خلينا نحكي الورشة التدريبية في موضوع اللي هو خلينا نحكي له علاقة بالسيارات الكهربائية والهجين، واللي هو كان موضوع البطاريات. زي ما انتم شايفين امامكم البرنامج الورشة، اللي هو طبعا اليوم عبارة عن مقدمة على موضوع البطاريات. راح يكون في معنا بعد ما انا اعطيكم شوي مقدمة عن المشروع، راح يكون معنا دكتور حسام خصاونة من الجامعة الأردنية، رئيس قسم هندسة الميكاترونكس، راح يعطينا محاضرة على الجنرال انترودكشن تو باتريز فاندمنتال اند ابلكيشنز، وراح تكون لمدة نص ساعة. وبعد هيك راح يكون معنا خلينا نحكي الباحث فلوريان رينبيك from Aachen University، وطبعا في ألمانيا، وهم متخصصين في جامعة آخن في هذا المجال، خاصة في مجال البطاريات، وراح يكون برضه لمدة نص ساعة. طبعا وبعد راح نفتح المجال للدسكشنز، راح تكون المهندسة رشا والمهندسة سارة معكم على أساس إنه مودريشن للدسكشن سيشنز. طبعا زي ما حكيت، هاي راح تكون عبارة عن السيشن الأولى أو الورشة الأولى، راح يتبعها العديد من الورشات التوعوية والتدريبية في مجال السيارات.
وين عند شو اسمه؟
سمحتوا لي بس يعني انه بس عملنا ميوت، يعني في ناس بجوز يكونوا شوي المايك بجوز انه لا. فال I think that might be we have some also guests with us from Europe that as we said that the presentations, the slides will be in English, but maybe some discussions will be in Arabic. So please apologize us that if we use the Arabic language in some cases. This is in order to increase maybe the benefits for such important work. يعني أنا إذا بتسمحوا لي بس إنه نعرفكم شوي في مشروع الإيكو كار أو السيارات الكهربائية والهجينة، تاخذوا فكرة. يعني إحنا معنا بجزء من الشركاء من كافة الجامعات الأردنية، وفي عنا طبعا إنه نحكي برضه من جامعات أخرى ومن مؤسسات ستيك هولدرز شركاء معنا في هذا المشروع. طبعا مشروع الإيكو كار هو عبارة عن، بيهدف هذا المشروع إنه لإنشاء أو تطوير خلينا نحكي قدرات الجامعات الأردنية في مجال السيارات الكهربائية والهجين. وإحنا بنعتقد إنه هذا المستقبل اللي راح يكون سواء في الأردن أو في المنطقة أو على مستوى العالم. يعني العديد راح تشوفوا إنه من خلينا نحكي شركات السيارات في العالم سنة 2030 راح تتوقف عن جزء إنه خلينا نحكي إنه تصنيع السيارات اللي بتستخدم الوقود الإحفوري، وراح تتجه كلها للسيارات الكهربائية. حتى إحنا حاليا جزء إنه علاقتنا مع وزارة الطاقة ومع شركات الكهرباء إنه فعلا إنه بما إنه في عندنا خلينا نحكي طاقة متجددة وإنتاج عالي، إنه يتم فعلا تطوير شبكات الشحن، ومما يؤدي إلى زيادة بصراحة استخدام السيارات الكهربائية في الأردن. واحتمال كبير إنه حتى المواصلات العامة مثل الباصات وغيرها راح تكون كذلك على الكهرباء. فإحنا في هذا المشروع لمدة 3 سنوات.
السلام عليكم.
وعليكم السلام. إحنا في هذا المشروع لمدة 3 سنوات راح يتم العمل. عفوا بس إذا سمحتوا يا أخوان، إنه إحنا بس راح نعطي مجال للدسكشنز ولا أي شيء في نهاية الورشة إن شاء الله. راح يكون عندنا نوعين من الدبلومة. راح يكون
طبعا أنا
عندنا
مش سامع الصوت، يعني هذا ما أخذ.
اذا مش سامع الصوت بيكون يمكن من عندك اتوقع ولا لا؟ يعني الاخوان الثانيين سامعين الصوت؟
تمام دكتور، سامعين صوتك.
بس بجوز واحد ما دخل على التلفون ما كبس الواي فاي، في كبس لازم يكبسه.
صحيح صحيح، يعني بتكون مشكله تقنيه عنده يعني. طيب يا اخوان، خلينا بس انه نكمل لانه شوي الوقت ضيق معنا والعدد المشاركين يعني عدد مميز وكبير، يعني انه فزي ما حكيت انه احنا بهذا المشروع نهدف انه الى تطوير مراكز التدريب المهني، وانشاء نحكي تطوير قدرات نحكي الفنيين، وخلينا نحكي اللي بيشتغلوا بهذا المجال، حتى يصير في عند المواطن الاردني بصراحه انه الكونفيدنس انه فعلا اذا انا امتلكت سياره كهرباء راح الاقي انه بالسوق انه فعلا كراجات واماكن تقدر تصلح لي هاي السياره وانه وتتابع صيانتها. كذلك راح يتم انه انشاء برنامج متخصص للمهندسين سواء في كليه الهندسه من مهندسين ميكانيك او ميكاترونكس او مهندسين كهرباء للتعامل مع هذا النوع من السيارات الكهربائيه والهجينه، وكذلك انه الاشراف على الفنيين الموضوع. طبعا احنا بهمنا انه في عندنا عدد كبير من المشاركين من مؤسسات وشركات مختلفه، واحنا عمالنا بنبني في هذا المشروع عباره عن الشبكه او النتورك اللي راح يكون فيه انه علاقه تعاون طول فتره المشروع وبعد المشروع مع المؤسسات الوطنيه والشركات الخاصه واصحاب الكراجات واصحاب المصلحه. فاحنا يعني بعض منكم بجزء انه اشترك معنا وعبى النموذج واصبح انه يعني شريك معنا في هذا المشروع، واذا في بعض الزملاء حابين انهم يشاركوا معنا فاحنا طبعا على الرحب والسعاده فيهم. وراح يكون زي ما حكيت انه خلال السنه الاولى راح يتم اختيار المساقات بالتعاون مع الجامعات الاوروبيه، وزي ما حكيت انا في عندي 8 جامعات من الاردن مشتركه في هذا المشروع حاليا، اللي هي الجامعه الاردنيه، جامعه البلقه التطبيقيه، نعرف ان جامعه البلقه لها فروع عديده، في عندنا جامعه العلوم والتكنولوجيا بالشمال كذلك مشاركه معنا، جامعه مؤتة من الجنوب، جامعه الطفيله التقنيه، بالاضافه الى جامعه ولي العهد جامعه حسين التقنيه، جامعه العلوم التطبيقيه، وجامعه الزيتون الاردني خاصه. فثمان جامعات مشاركه في هذا المشروع، بالاضافه طبعا عندنا 6 جامعات اوروبيه، واحدى الجامعات اللي هي جامعه اخن تعتبر يعني من الجامعات المميزه على مستوى العالم، وترتيبها من افضل 100 جامعه متخصصه في مجال بصراحه الهندسه الميكانيكيه وهندسه المركبات والهندسه الكهربائيه وجميع انواع الهندسات. طبعا في عندنا جامعه هوكسر الالمانيه، كذلك في عندنا جامعه بودابست وهم متخصصين في مجال السيارات الكهربائيه والهجينه، بالاضافه طبعا عندنا شركاء من اسبانيا ومن ايطاليا ومن الدبلومه. ان شاء الله احنا خلال السنه الحاليه راح نجهز كل مساقاتها، راح يتم كذلك انه تجهيز مختبرات في الجامعات الاردنيه ال8 مشاركه باحدث التكنولوجيا المختصه في هذا المجال. سيتم عقد العديد من الورشات للشركاء بالمشروع، راح تكون في الدول الاوروبيه، وبعد هيك سيتم عقدها في الاردن. واحنا الحمد لله هلا تعافينا من تدريجيا من كوفيد 19، وبالتالي راح يصير في عندنا ورشات في الجامعات الاردنيه ال8 مشارك في المشروع، وسيتم دعوتكم ان شاء الله لحضورها والاستفاده من هاي الورشات. راح تكون كلياتها ورشات مجانيه، وزي ما حكيت راح يتم انشاء مختبرات في مختلف الجامعات الاردنيه بعد اعداد الخطط الدراسيه في هذا المجال. طبعا انه احنا ان شاء الله يعني راح يتم انه اعتماد خطه الدبلوم من مختلف الجهات المعنيه في الجامعات الاردنيه. انا بصراحه ما بدي اطول عليكم اكثر، فبالنسبه للورك باكجز بجوز ما في وقت انه نحكي فيهم، بس انا حاب انه نحكي شوي. في عندنا احنا ويب سايت، يعني هي الويب سايت موجود، فممكن انه فعلا تقدروا تزوروه وتشوفوا معلومات المشروع موجوده على الويب سايت. يعني هي انه تقدر انك تاخذ الويب سايت وانه كامل المعلومات احنا بننزلها على الويب سايت. هلا ممكن انه يعني هاي الويب سايت شايفينه احنا امامنا، واحنا كل نشاطات المشروع النيوزلترز خلينا نحكي حتى الورشات اعلان عنها الشركاء كلاتهم موجودين عندنا على الويب سايت. يعني فالمهندس ان شاء الله راح تنزلوا عندكم على اللينك على اساس انه اي حدا بيحب انه صراحه يدخل يشوف الويب سايت انه بيقدر نشوف باي وقت اخر. وعندنا طبعا صفحه موجوده على الفيسبوك. طبعا الصفحات الاخرى موجوده، ممكن فعلا يعني الفيسبوك هاي موجود كمان، راح يكون مهندس رفقه كذلك على الشات مايك اذا في ناس يعني. وفي عندنا كذلك انه طبعا على اليوتيوب برضه في عندنا برضه قناه خاصه كذلك بالمشروع، واحنا نشاطات كذلك ننزلها على اليوتيوب. فيعني احنا بنرحب فيكم مره ثانيه، وزي ما حكيت هاي الورشه الاولى. اسمحوا لي انه اقدم زميلنا رئيس قسم هندسه الميكاترونكس في الجامعه الاردنيه دكتور حسام خصاونه. دكتور حسام تعطينا المحاضره على الانترودكشن تو باتريز، فالكل ان شاء الله ذواق لمحاضرته. And after that, we will listen to Dr. Florian. For Mr. Florian, I think that now we have the record, but when you start the presentation, Florian, we will stop also the record according to your request. So, Dr. حسام كانت تفضل هلا، واهلا وسهلا فيك.
شكرا. بس ده ممكن اكون الهوست مشان اعمل شير السكرين. اوكي
تمام، هلا بنعطيك الهوست دكتور.
لا تمام.
هيك تمام.
بسم الله الرحمن الرحيم. I'm Dr. Hussam Khassaune, an associate professor and the chair of the Mechatronics Engineering Department at the University of Jordan. I got my bachelor degree in Mechatronics Engineering from the University of Jordan. Then I got my master's and PhD from Ohio State University. And my research was mainly in energy storage systems and especially in batteries. So today I will be talking about a general introduction to batteries. I will start this workshop today with a talk on the fundamentals and applications of batteries, and then my colleague Florian from University of Aachen will talk about aging and second life of batteries. All right. The energy storage can be defined as the conversion of electrical energy into a form in which it can be stored safely and efficiently until converted back into electrical energy to be used again. There are several energy storage technologies that can be used for many applications. For example, we have thermal energy storage, where the energy is stored as thermal, and then it can be retrieved back when needed. Pumped hydro energy storage, where you can use the electricity to pump water from a lower level to a higher level, and then you can generate electricity back when needed. We have the compressed air energy storage, where energy is stored as a compressed air in a vessel or container. We have flywheel. We have fuel cell, which uses hydrogen as storage. We have the capacitors, supercapacitors, and superconducting magnetic. Of course, for electric vehicles and hybrid electric vehicles applications, battery, fuel cell, and supercapacitors are the most suitable of these technologies. But today we will only be talking about battery energy storage. Maybe in the future we can talk about different technologies. Batteries can store energy and are used to power a large variety of devices, ranging from micro batteries, very small batteries that can maintain the memory of computers and ICs, up to big batteries that can power the electric cars, or even bigger batteries that can use that are attached to renewable energy to stabilize the electricity grid. Batteries that can only discharge once are called the primary batteries, like the AA, AAA batteries, just like in this photo right here, the Energizer. So this is a primary battery. This battery, once you use it, you just have to recycle it. You can't use it again. The batteries that can be recharged are called secondary batteries, and we will be talking mainly about secondary batteries that are used in, like for example, in mobile phones, in laptops, in EVs, and with grids. Those are secondary batteries. So secondary batteries and batteries in general consist of a positive and a negative electrodes or poles. In a charged battery, when the battery is fully charged, electrical energy is stored inside the battery in a chemical form in the positive and negative electrodes. The chemical energy will be released as electrical energy when the battery is being used and being discharged. Secondary batteries can be charged again using electricity. So the conversion will be inverted. So the electrical energy will be converted to chemical energy when we charge it, when we are charging the battery. Secondary batteries generally have a very high energy storage efficiency. It can reach 90% or sometimes higher than 90%, meaning the losses are very minimal. Now, if we want to talk about batteries as an application for electric mobility, for electric vehicle, hybrid electric vehicle, plug-in electric vehicle, we need the storage needs to satisfy and fulfill certain requirements to qualify to be a good candidate for electric mobility. The key requirements are number one, high energy density to ensure a satisfactory range, meaning that the storage should have enough energy so that the car can drive for longer distance. Also, we would need a storage with high power density so that the user or driver can accelerate easily. So basically, we need an energy storage that can deliver its energy fastly, in a fast manner, so that when you press the gas pedal, the needed electricity will be delivered quickly so that you can accelerate. Also, we would need long and maintenance-free lifetime. We need long lifetime and maintenance-free. We need safe operation, because here the human beings' lives are at stake. So you don't need anything that is unsafe. And also we would need an end-of-life disposal with a minimum environmental impact. And also we need high efficiency to maximize the profit of the EV user. So in order to evaluate the different technologies that can be good candidates for electric mobility, we can look at this Raguni plot. They call it Raguni plot. The Raguni plot is power density on the y-axis and energy density on the x-axis. So for storage, it's very important to understand that both power and energy are important factors. So as I said here, we see the power density versus the energy density for different energy storage technologies: capacitors, supercapacitors, flywheels, batteries, and fuel cells. So the ideal place on this plot would be the top right corner, would be here. So here is the ideal place. It's the place where you have the maximum or very high power density and very high energy density. Unfortunately, we don't have this option right now. So typically, capacitors and supercapacitors, they have very large power density, but with low energy content. So they can give you energy very, very quickly, but they will give you very, very little energy. So that will not be enough to drive you even from maybe 100 meters of distance. So they are very, very suitable for relatively fast power-based services like, for example, transient voltage stability in grid. On the other hand, batteries and flywheels, they have reasonably good amounts of power and energy densities. So for example, Tesla cars, they have about 90 to 100 kilowatt hour in energy. So that's good to drive for like 400 kilometers. And also the power of the battery is around 50 kilowatts. So that would give you a good acceleration. So when you need the energy fast, it will be delivered to you fast. So ideally speaking, and this is a topic of research, a combination of batteries and capacitors will be ideal for electric vehicles. On the other hand, fuel cells have very low power density, but very high energy density. So basically they will give you a good amount of energy, but they will not be able to deliver the energy fast enough in most cases. So that's why even in fuel cell vehicles, you would need batteries. You would need batteries as well. So basically, like the best candidate is batteries. You cannot drive electric vehicle without the battery. So if we want to dig deeper and talk about the different battery technologies available in the market, we will talk about four main technologies. Of course, we have many more, but we don't have much time. So we'll talk about the conventional lead acid. We'll talk about the nickel cadmium, the nickel metal hydride, and lithium ion. So the lead acid battery is basically a mature technology. We're limited, it's very mature and very well established, let's say. So it's the oldest type of battery in the consumer use. And the material used is lead dioxide. So lead dioxide.
لو سمحت دكتور، لو سمحتوا بس تعملوا ميوت، اي حدا بدخل يعمل ميوت يعني من اوردر انه نكمل المحاضرة بشكل متواصل. شكرا.
Thank you. So the cathode is made of lead dioxide and the anode is made of metallic lead, just regular metallic lead. And the electrolyte in between the cathode and anode is sulfuric acid. Applications of lead acid battery is the internal combustion engine ignition. So it's used in the conventional car, the gasoline, the diesel car, to help the engine in the ignition. Also, it's used as an interruptible power supply, UPS. And also, it's widely used with renewable energy. It's used with renewable energy systems. The advantages of the lead acid battery, they are mature, as we said, they are cheaper than others, simple to manufacture, they have low self-discharge, and this is a good basically. Self-discharge meaning that when you leave the battery on the shelf or like unused, it will not discharge itself internally. So this is good. This is good characteristic for the lead acid. They can give you a high discharge current and they are reliable technology. However, they have multiple disadvantages. They have low energy density. So you would need a bigger amount of batteries connected together. There's a problem of the sulfation of electrodes. So the cycle life will be shorter. So a limited number of full cycles, meaning the lifetime is shorter for lead acid batteries. And also lead is a toxic and it's not environmentally friendly. So recycling is challenging for this kind of battery. But basically this is not really used in electric mobility. The second technology is the nickel cadmium battery, NICD. The advantages of nickel cadmium batteries, they are the higher number of cycles compared to the lead acid. They have better energy and power density than lead acids. They have low internal resistance, and they perform well at low temperatures. They have long shelf life, so you can store them for longer period of time, and fast recharge. However, nickel cadmium, they have low energy density as compared to the nickel metal hydride and lithium ion batteries. And another disadvantage in the nickel cadmium, they call it the memory effect. The memory effect, it means that when you don't discharge and charge the battery fully for some time, it's kind of like the battery will forget its original capacity. So from time to time, you would need to do a full discharge, a full charge for the battery. Also, because of the cadmium toxicity, it's very toxic. Nickel cadmiums are considered environmentally unfriendly, and the recycling is very problematic. For this reason, actually, nickel cadmium have been restricted in the European Union countries. So this is a very big disadvantage. They are only used now on alarm systems, on emergency lighting, and some portable power tools, and they are not used in electric mobility. The third type is the nickel metal hydride battery. They share the same cathode with the nickel cadmium that we just talked about. The anode is a metal hydride metal, which enables higher specific energy, meaning higher energy density than nickel cadmium. This battery also has very good cycle life. It also has is less affected by the memory effect than the nickel cadmium. And it's more environmentally friendly. However, it's very sensitive to overcharging, so that's why it requires a complex charging system. Overcharging can destroy the nickel metal hydride. And the disadvantage, the other one, is it has lower efficiency than lithium ion. Currently in the market, it's mainly used in Toyota Prius and Honda Insight and Ford Escape. Now, the final technology that I'll be talking about today is the lithium battery. Lithium batteries are the most advanced battery type based on energy density. So they have the best energy density in the market. There are 4 basic versions of lithium batteries. We have lithium metal, lithium ion, lithium polymer, and solid electrolyte lithium battery. The first 2 types are based on the nature of anode active material, while the other 2, they replace the liquid electrolyte with solid electrolyte for safety, like it's more safe. However, the most well-known and the most used battery in the lithium battery family is the lithium-ion battery. The advantages that they have a higher cell voltage than other batteries on the market. They have near flat voltage during discharge. So basically the drop in the voltage when you discharge is very minimal. So it's easier to deal with them in power electronics and DC-AC conversion. They have low self-discharge and their efficiency is excellent. However, they are expensive, they are delicate, and they require special protection circuit during charge and discharge. And under unsafe conditions like higher temperature and overcharging, lithium-ion batteries can catch fire or can even explode. And this is one serious problem with lithium. Also, in the ongoing research now, we're talking about 2 promising cathodes material that can be used in combination with lithium ion. We have the sulfur, the lithium sulfur battery, and lithium air battery. We don't have time now to talk about them, but they have a good potential in the future. Of course, there are many cars that use lithium-ion batteries. We just mentioned a few of them. The Ford Fusion uses lithium-ion, or think lithium polymer, I think, but it's lithium battery. Nissan Leaf uses lithium-ion, and Tesla, the very famous electric car, Tesla, uses lithium-ion, and many other manufacturers as well. So now, after we got introduced to different technologies, let's look at them on the same plot, the Raguni plot, but now with specific types of battery technologies. So if we look at this point, so this point is the electric vehicle goal. So the electric vehicle goal is to get this amount of specific energy and this amount of specific power. Of course, specific power means power density. Specific energy means energy density. For plug-in hybrid, the goal is less because we have the internal combustion engine, and it's the same with the HEV as well. So the target, our target is right here, and we can see that the best target that can achieve this is the lithium-ion. Lithium-ion is the closest technology to the EV goals. However, like if we talk about only hybrid, the nickel metal hydride is enough technology for hybrid electric vehicle. All right. So again, if we look at the power density, we're looking at acceleration. So the more we go to the right, we have better acceleration, and the more we go here, we have better range. So lithium-ion gives us good range and also good power capability. Now, the power of a battery pack depends on how we connect the batteries inside the pack. So here is a battery pack. I think this is for Tesla, I think, I'm not sure. But this is a battery pack to the right. So it consists of battery cells like this. So the battery cells can be connected either in parallel or in series, or a combination of parallel and series. So if we connect the cells in parallel, we would have a higher current. If we put them in series, we would then have a higher voltage. In an electric vehicle, many individual cells will be combined into a battery pack. For example, Tesla, the 85 kilowatt hour battery contains 7,100 individual cells. And also, each battery pack has a battery management system that monitors the state of each individual cell and manages how the individual cells are charged and discharged. Of course, this is very important to achieve safe operation, long cycle life, and optimal performance of the system. The two most common lithium-ion batteries are cylindrical and prismatic. So cylindrical, like this one in blue, and prismatic, like the other one. Typically, cylindrical lithium-ion cells are used in electric vehicle technologies as they provide the longest cycle life. They have high safety standards, and they are cheap to produce. The disadvantage of the cylindrical cell is that they are less efficient in volume packing because of the shape. You will have some spaces and empty spaces. The prismatic cell, however, are more volumetric efficient. That's why they are used in mobile phones and tablets, because they are very efficient in volume. So let's just briefly talk about the working principle about lithium-ion. Basically, all of them, they have very similar working principles. So we will only talk about lithium-ion for time, like to keep the time. As I said before, any battery has anode, cathode, and electrolyte. The negative electrode is the anode, the positive electrode called the cathode, and in between it's called the electrolyte. So the electrolyte is typically a liquid, but sometimes it's solid, sometimes it's solid, and it separates the two electrodes from contacting each other. So as I said, we'll take lithium-ion battery as an example. So when the battery is charged, the lithium ions are stored in the negative electrode, the one in the orange color. But they are experience a driving force to migrate towards the positive electrode. So here we see the formula. So LiC6 will be broken into C6 plus lithium ion. It's Li plus and electric charge. So the electrolyte will allow the lithium to pass from the negative to positive electrode. Now, the driving force for this is chemical, which means that the lithium ions, the Li plus, prefer to bond in the positive electrode material, the FePO4. The larger the bonding strength, it means the larger the voltage of the electrode. So by combining the electrode with a large bonding strength towards lithium with an electrode with a weak bonding strength, the difference between the two potentials is made larger, and this is what we call the battery voltage, the battery voltage. Therefore, the battery voltage represents the chemical driving force to move the lithium ions from the negative electrode to the positive electrode. Now, the electrolyte in the middle only conducts ions and it does not conduct electrons. So the only path for the electrons to move is through the resistance, the outer resistance, the external circuit. So this causes a current in the outside circuit, and if we put any resistance or any load, this current will operate this. For example, if you put a light, this light will be on. If you put a motor, the motor will start rotating. So the electrons will travel through the resistance or the external circuit to combine the lithium ion in the positive electrode. So here we see that the lithium ion and the electrode, they combine together to form the LiFePO4. Okay, so this will continue until there is no lithium ions anymore, and at that time we call the battery is discharged, is fully discharged, and cannot generate electricity anymore. So,
Dr. Hussam, may I ask?
Yes, please.
Excuse me, what is the electrolyte solutions? Contains of what?
It's different. It's different. Like I said before, we have different types of lithium batteries depending on the electrolytes. So different lithium ion like technology, they have different electrolytes. It's a solution with a separator. This solution and separator will allow the lithium ion to pass, but it will not allow the electrons to pass. So basically, it's a solution. It's a solution. In the terms of lithium ion, it's a liquid, but because the liquid, they say it's not safe. Now we're talking about lithium air, where probably the electrolyte will not be liquid. It might be solid. It might be gas.
May I add something?
Yes.
So what Hussam just explained is absolutely correct. So there are lots of different ways to do this. Often we see an organic electrolyte in the lithium-ion batteries because water-based electrolytes are not suitable for the high cell voltages. And there we see LiPF6 as a conductive salt and DC, EC, and EMC as the solution material used for this.
So there are no one solution that is used.
Correct.
We have different solutions for different types, for different technologies. Okay. So basically, I'm done with the working principle. That's very basic. Of course, we have many more details that we don't have time to go through right now. I'll just jump now to the performance parameters. So to better understand the operation of batteries, we need to understand some key performance parameters: capacity, state of charge, coulombic efficiency, energy efficiency, energy density. We already talked about energy density, and C rate. So we'll start with the capacity and state of charge. So to determine how much a battery is charged in a percentage, we use the state of charge. So 100% means fully discharged battery. 0% represents fully discharged battery. 50% means right in the middle, just like that. So to better understand, let's look at the voltage when lithium-ion battery is discharged. So it's this figure. In this figure, it's the voltage, it's the like the electrode, the positive negative electrode voltage difference, and in the x-axis it's the state of charge. So here we start with a fully charged battery, and then we go this way to a fully discharged. So it's a discharge voltage curve. As we can see, okay, that the voltage generally decreases during discharge. This is because the lithium ions that have the largest chemical driving force will go first from the negative to the positive electrode. So that's why the voltage will start dropping. Okay, so for batteries, okay, so we can know that we reached the fully discharged state by measuring the voltage. And also we can know that we reach the fully charged state by also measuring the voltage. So for example, here we start with like 4.3 volts when the battery is fully charged. And then when we start using the battery, the voltage will drop until it reaches about 2.3, something like that. Okay. The capacity is given like usually in amp hour. 1 amp hour means that the battery can sustain or can provide a current of 1 ampere for 1 hour. If we convert this to columns, will be 3,600 columns. But we don't use columns. We use ampere hour generally in batteries. So that's why if we look at this figure down here, we have the voltage during the discharge. So here is the voltage during discharge. So this is called discharge capacity. And then if we start charging, then the voltage will start doing the opposite. And the voltage will start increasing till we reach the 100% state of charge. So at this point, we have 100% state of charge. At this point, we have 0%. And this point, we have 100% again. So the capacity here is called discharge capacity, and the capacity here is called charge capacity. Ideally, they are equal. But unfortunately, that's not true. And we'll talk about this now. So the ampere hours during the discharge is not really the same as the ampere hour during the charge. And that's what we call that's what we call the coulombic efficiency. So the coulombic efficiency is the ratio between the discharge and charge capacity. So if we have any value less than 100%, so it means that the discharge capacity is less than the charge capacity, meaning that we take from the batteries less ampere hours than what we gave to the battery. So this is one type of losses. This is one type of the losses. So the other type of loss is called the energy efficiency, or the other type of efficiency, sorry. It's called the energy efficiency. So this is simply the ratio of the input and output energy. And the input and output energy are only the area under the curve. So the area under the curve is during the discharge is the energy out of the battery, and the area under the curve when we have the charging is the energy we give to the battery. And again, it's not 100%. It could be 90, 91, 95, maybe less. So this is the energy efficiency. And basically the energy efficiency here, again, it's not in joules, it's not in kilojoule. Usually it's, so this is voltage, and the capacity, as I said, it's ampere hour. Voltage multiplied by ampere hour, it's watt hour. So we use basically watt hour as the energy unit in batteries. Usually lithium ion have around 90% energy efficiency. But again, this is not fixed. It depends on how fast I will discharge the battery. We'll talk about this in a couple of slides. Energy density, we already talked about the energy density. It's the, I mean, there are two types of energy density. One is per unit, per unit weight. We call it gravimetric. So it's watt hour per kilogram. And the other one is volumetric. It's watt hour per liter. The most important among these is, like, the more relevant to electric vehicles is the gravimetric. It's the watt hour per kilogram, because the weight is the most important factor. It's not really the volume. Like in the car, we have good space to put the batteries. For example, in the mobile phone, the volumetric is very important, because we need it to be very compact. Okay, in the electric vehicle, we need it to be very light, as light as possible. So again, here at the top corner is the best. It's the best technology. It's the one with the best gravimetric energy density and the best volumetric energy density. For example, lithium air is leading this way. Lithium air is leading towards this optimum value. Other than that, we can see that lithium ion is doing really well in both sides. Okay. Also, there's zinc air. It's promising. It's still not used in any electric vehicle though.
Excuse me, Hussam, just one question.
Sure, doctor.
This weight for the car or for the battery? I don't understand.
For the battery. It's the weight for the battery.
Or the car?
For the battery. It's the weight for the battery. So, for example, if lithium ion is here, it's 300 watt hour per kilogram. So each kilogram of lithium ion battery will give you approximately 300 watt hour of energy. But okay, this is very important. I mean, it's more important than volumetric. I mean, both of them are important, but it's more important than volumetric, because in the car, we might have some space, but the limiting factor is basically the weight. We don't want to have a technology that is very, very huge, that is now a burden on the car. So when we move from gasoline to electric vehicle, we don't want the battery to be, you know, like to have much more weight than the internal combustion engine. We don't want this. We need the car to be light. When it's light, it's more efficient, and it's more green, right? It's more green. It uses less energy. So this is for the battery.
Dr. Hussam?
Yes.
You are exceeding your time. Please,
have 2 minutes. I'm almost done. I'm almost done. Yeah. I need 3 slides more. Now let's talk about C rate. C rate is a very important factor. It's a very important factor, and it's a very let's say dimensionless, let's say, method of measuring the discharge and charge current. We can control the charge and discharge rate by the amount of current that we charge or discharge the battery. Higher currents will discharge and charge faster. Low current, slower, will do that slower. Now, because the total charge or discharge time, the time depends on both the current and the battery capacity, it's good to combine them together in one parameter. It's called the C rate. The C rate takes into account the capacity of the battery and the current. So when we say C over X rate, it represents the current to charge or discharge the battery to its full capacity in X hours. For example, if we say C over 20, so if we are charging or discharging the battery by a rate of C over 20, this means that we will charge or discharge the battery in 20 hours. So the current is very small, right? It's a very small current. If we say 20C, okay, it means that we will charge and discharge the battery in 1 over 20 hours. 1 over 20, it's 0.05, it's 3 minutes. So you can see that it's very huge current. So why is that important? Because the efficiency is a factor of C rate. So when we say that the efficiency, here we mean the energy efficiency, not the coulombic efficiency. So when we say that our efficiency is 97%, well, that's true when your C rate is very, very small. But when your C rate is very large, like 5, 6, 7, 10, then you can expect the efficiency to drop to 90 or maybe 85%. So it's not really true to say the battery efficiency is just 90%, and if you don't continue the statement, that's wrong. You need to define the C rate. It means how fast you're charging and discharging your battery. So this is a very important factor. The effect of the C rate on performance is as we said, when the currents are large, the battery capacity will change. Okay, so if we look at this curve basically it's a very, very slow charging. Here it's charging. So we can see that we start with V minimum and we reach V maximum, okay, through this very comfortable curve. Basically this curve, it's very close to the ideal characteristics, and that's very good. However, if we go to a faster, like 20C, this is a very, very, very fast charge. We can see that we reached here very fast. Basically, we are not using the complete amount of the capacity. We are just using this amount of the capacity. So it's very important to understand this. To maximize the capacity, or like the observed capacity, the actual capacity, it's better to charge and discharge the battery slowly. And basically by doing this, you will extend the life. And my friend Florian will talk about this in a second. The opposite happens during discharge. So if we discharge with a very low current, the curve looks like this. But if we do it very, very fast, we are just using a portion of the capacity. And that's far from ideal. There are many more to talk about, but I know the time limits, so let me conclude. Energy storage is defined as the conversion of electrical energy into a form, thermal, maybe electrical, maybe magnetic. This form can be used later on whenever needed. Electric mobility requires energy storage system with a high energy density and high power density. The electric mobility also requires maintenance-free lifetime for the battery, safe operation, and high efficiency. There are various battery technology in the market today. We talked about some of them. Lithium ion is the best potential right now in electric mobility, and we understand that discharging and charging current have a big role on the performance of the battery. Thank you.
Thank you, Dr. Hussam, for your participation. And the floor is now for Florian from RWTH University, Aachen University. And please, from you all, can you please, after this workshop, evaluate our workshop? رجاء من الجميع قيم الورشة بعد انتهائنا، وشكرا جزيلا. أكيد في discussion panel بعد انتهاء